The kernel is the core component of an operating system. It is essential software that sits between applications and physical hardware. The kernel manages all hardware resources and enables communication between software programs and devices. Every operating system, whether on your computer, phone, or tablet, has a kernel working silently in the background to make everything function. The kernel performs 4 essential functions. First, it manages processes and decides which applications get CPU time and when. Second, it handles memory by allocating storage space to programs and ensuring they do not interfere with each other. Third, it controls all devices like printers, USB drives, and network cards. Fourth, it manages files and folders on your storage devices, allowing you to save and retrieve data. These functions work together to keep your system running smoothly. The operating system is structured in layers. At the top are your applications and programs. In the middle is the kernel, which operates in protected mode and is the most powerful part of the system. At the bottom is the actual hardware and devices. The kernel acts as a bridge, translating requests from applications into commands that hardware can understand. This separation protects the system and ensures stability. The kernel uses several advanced techniques to manage memory. Virtual memory creates a larger memory space than physically available by using disk storage. The buddy system allocates memory in chunks that are powers of 2, which reduces waste. Slab allocation pre-prepares memory blocks for frequently used objects, making allocation faster. Paging divides memory into fixed-size pages and can move pages to disk when RAM is full. These techniques work together to provide efficient memory management. The kernel must decide which process gets to use the CPU at any given moment. Round robin gives each process an equal time slice. Priority scheduling runs the most important processes first. The completely fair scheduler ensures fair distribution of CPU time based on virtual runtime. First come, first served executes processes in the order they arrive. Preemptive scheduling can interrupt a running process if a more important one arrives. Multi-level queues use different scheduling methods for different types of processes. These algorithms ensure fair and efficient use of CPU resources. When something needs immediate attention, like a keyboard press or disk activity, the system sends an interrupt to the kernel. First, the CPU detects this signal and saves its current work. Second, the kernel identifies the type of interrupt. Third, the top half of the interrupt handler executes critical time-sensitive tasks immediately. Fourth, less urgent work is saved for later processing in what is called the bottom half. Finally, the interrupted process resumes where it left off. This process happens thousands of times per second. When multiple processes access the same data, conflicts can occur. Spin locks make a process wait by constantly checking a lock, useful for short waits. Mutexes put a waiting process to sleep until the lock becomes available, better for longer waits. Semaphores use a counter to allow limited concurrent access to resources. Read Copy Update lets readers access data freely while writers update copies, which is ideal when more processes read than write. These techniques prevent data corruption and ensure all processes work together correctly. A deadlock occurs when processes get stuck waiting for each other indefinitely. The kernel prevents deadlocks through 3 approaches. Prevention eliminates the conditions that cause deadlocks before they occur. Avoidance carefully grants resource requests to prevent circular dependencies. Detection and recovery identifies when deadlocks happen and breaks them up. For a deadlock to occur, 4 conditions must exist simultaneously. Resources must be exclusive. Processes must hold one resource while waiting for another, resources cannot be forcibly taken away, and there must be a circular chain of waiting. The kernel uses various strategies to prevent these conditions from occurring.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.